For months, the universe has been holding its breath. Hidden behind the sun, far beyond the reach of our telescopes, the mysterious interstellar traveler known as 3I Atlas was silent, until now. At the dawn of October 30th, 2025, that silence begins to break. The object is about to re-emerge from behind the sun, and with it comes one of the most anticipated moments in recent astronomical history. A fleeting window, from October 30th to November 6th, could change everything we know about these visitors from the stars, and the question that echoes among scientists is both simple and profound. Can we touch it? Of course, not in the literal sense of landing a spacecraft on its surface. That would be almost impossible. But could one of our distant probes, scattered across the solar system, cross the tail of 3I Atlas and touch it with instruments sensitive enough to collect data from its passing dust and gas? If so, it would mark the first direct physical interaction with an object born beyond our sun. To understand what is unfolding, we need to trace where 3I Atlas is now. After looping behind the sun, it is currently traveling between the orbits of Earth and Mars, glowing faintly as solar radiation heats its icy surface. That energy turns frozen material into vapor, forming a long glowing tail, the cosmic fingerprint of a comet. Yet 3I Atlas is no ordinary comet. It is a messenger from another star system, the third confirmed interstellar object ever discovered. Following Oumuamua and 2I Borisov, each time such a visitor appears, it challenges our understanding of planetary formation, chemistry, and the boundaries of our cosmic neighborhood. And this time we might have a chance to study one up close, perhaps closer than ever imagined. Across the solar system, numerous spacecraft quietly orbit planets or journey through deep space. Among them, two stand out as potential witnesses to this encounter: the Hera mission, operated by the European Space Agency, and NASA's Europa Clipper. Both spacecraft are currently en routes that place them within the extended region of 3I Atlas's trajectory. And that coincidence opens up an extraordinary possibility. If the geometry of space, sunlight, and motion aligns just right, these probes could actually pass through the outer layers of the comet's tail, a stream of gas, dust and charged particles stretching millions of kilometers into space. Even a brief passage could allow their instruments to record changes in temperature, plasma, radiation, or even capture molecules never before detected in our solar system. As 3I Atlas approaches perihelion, the closest point to the sun, it begins to release its volatile compounds, forming that bright trail. By October 30th, it will move from behind the sun into our line of sight again. And at that precise moment, the two spacecraft will be near the region where the tail is expected to form. This is no science fiction. It's a narrow, real opportunity, one that could reveal secrets carried across interstellar space for billions of years. But how can such a mission even happen? Most of these spacecraft are not designed to change direction suddenly or activate instruments on short notice. Their cameras and sensors are often powered down to conserve energy during long cruises. To capture the 3I Atlas event, mission teams would need to reprogram onboard systems, recalibrate cameras, and possibly redirect antennas to point toward a moving target hurtling through the void. It would require planning, coordination, and a fair amount of luck. Yet even a partial success could make history. This is where space exploration shows its poetic side. Humanity's machines, tiny specks of metal drifting in the dark, possibly brushing against a visitor from another star. For centuries, we've looked up and wondered what lies beyond. Now one of our creations might finally touch that mystery. To touch 3I Atlas means something far more subtle and scientific than it first appears. Today it's not about physical contact, Amosim, it's about interaction, about entering the comet's environment and reading its invisible signature. When a comet like 3I Atlas approaches the sun, it releases streams of gas and microscopic dust particles that become ionized by solar radiation. This mixture forms an enormous plasma tail, stretching millions of kilometers behind it. Crossing through this cloud, even for a few moments, could allow a spacecraft to collect data on elements that were born around another star system, offering direct evidence of materials beyond our cosmic cradle. The Hera mission, designed primarily to study asteroid impacts, and the Europa Clipper, intended to explore Jupiter's icy moon Europa, were never meant to chase comets. But space, as always, surprises us. Their current trajectories put them in positions where a small adjustment could let them intersect with the path of 3I Atlas's tail. It's an opportunity that will not come again. However, there are serious technical and bureaucratic hurdles. To activate instruments for such an unplanned study requires permission, reallocation of data budgets, and coordination between multiple space agencies. Every maneuver burns precious fuel, and every change in direction can risk mission safety. Still, for many scientists, the potential reward far outweighs the risk. Imagine detecting new molecules or isotopes unknown in our solar system, fragments of another world, perhaps even remnants of another sun. That would change our understanding of how matter travels through interstellar space, how planetary systems exchange material, and maybe even how life's ingredients spread across the galaxy. This very idea is shaping future missions. The European Space Agency already envisions a project called Comet Interceptor, a spacecraft placed in a strategic orbit near the Lagrange Point 2, patiently waiting for the next interstellar visitor. Once detected, the interceptor would launch from its parking orbit, accelerate and meet the object head-on, carrying specialized cameras and sensors built specifically for such encounters. It would be the birth of a new branch of space science, real-time interstellar interception. If Hera or Europa Clipper succeed in observing even a fragment of the 3I Atlas's tail, it will mark the first tangible contact with material from another star system, a turning point in human history. We will have reached, not just metaphorically but physically, across the stars. For now, all eyes and instruments are focused on the days ahead. From October 30th to November 6th, the solar system becomes a stage for an extraordinary alignment of chance and technology. A silent meeting between an alien traveler and the creations of a species that refuses to stop looking upward. Whether or not these probes manage to collect data, the attempt itself carries meaning. It represents the very essence of human curiosity, the drive to reach, to learn, to connect with what is distant and unknown. In the darkness of space, between the orbits of Earth and Mars, a fragment of another world drifts silently. Glowing under the light of our sun, for billions of years it has traveled alone, and now for a brief instant it may be touched, not by human hands but by human ambition. The universe doesn't often give second chances. This may be one of them. The window is narrow. The timing is fragile. Between October 30th and November 6th, two spacecraft may pass through the breath of an interstellar traveler, the 3I Atlas. If they succeed, humanity will have reached farther than ever before. Beyond the data and the science, there's something poetic in this pursuit. To touch something that came from another sun is to touch our own origins. It reminds us that we are part of a vast living universe, still full of mysteries waiting to be felt, studied and understood. The countdown begins. Soon we'll know if humanity truly managed to touch the 3I Atlas.